Okay, so today we're going to go over week 5, problem 4.2, and this is about erasures. So in this problem, we explore why we need n plus 2k points to correct for k general errors. Suppose Alice is trying to send a message of length n to Bob, but she knows that if she sends a message, k packets will be corrupted. Alice knows that by Berkeley Camp Welch, she should send n plus 2k packets to ensure that the message can be decoded. By considering an adversary, Eve, who can corrupt k packets of her choice, show that n plus 2k is the minimum number of packets to send to be able to decode the message. In other words, if Alice sends fewer than n plus 2k packets, then the message could potentially not be uniquely decoded. So what is this saying? Basically, the important part of this question is the last couple lines. In other words, if Alice sends fewer than n plus 2k packets, then the message could potentially not be uniquely decoded. So we're saying that there is Eve who can, so let me make a new page. There's Eve who can replace k packets or corrupt k packets, corrupt k packets. And we're trying to say that in order to account for this, in order to determine a unique polynomial, we have to have n plus 2k packets let me see, Alice has to send in order for Bob to decode. So why is it n plus 2k? Why can it not be less than n plus 2k? Well, let's take the general case where, so first of all, Alice is going to have to send at least n packets to determine a message of length n. And then she's going to send some additional amount of packets, L, in order to account for this corruption. And so in doing this, we will see that n plus L, so let me write this down, packets, and then n plus L minus k, uncorrupted packets, sorry, number of uncorrupted packets will be n plus L minus k, because k packets are corrupted. So this is what Bob will look for. He will look for these n plus L minus k uncorrupted packets. So we look for n plus L minus k packets and determine a polynomial from them. But Bob doesn't know which packets are corrupted or not. So what Eve could do is she could take so Eve could then take n plus L minus 2k of the correct packets, and then construct another polynomial Q that passes through these points. So she could take n plus L minus 2k of these packets, construct a polynomial Q that passes through these points, and then corrupt k packets such that when n plus L minus k is read, you'll have n plus L minus 2k of these corrupted packets plus k packets that will result in Q. So when Bob reads, he will get n plus L minus 2k correct packets, k incorrect packets to form Q. Because Eve will determine Q based on n plus L minus 2k packet packets and the k corrupt packets. So then she could put in whatever message she likes by sending these k packets. So when is this not possible? This is not possible when n plus l minus 2k already determines, if n plus l minus 2k packets determines a polynomial of degree n minus 1, then this is not possible. Why is it not possible? Because we cannot add any extra points to change the polynomial at a point where the polynomial is already determined. If the polynomial is already determined, then we can only add points from that polynomial. The reason that Eve can, if n plus, and this happens when n plus l minus 2k is greater than or equal to n. If n plus l minus 2k is greater than or equal to n, then you can determine a polynomial of degree n minus 1 from these packets. And so Eve will not be able to correct additional packets. If it's less than n, then Eve will be able to corrupt k packets because the polynomial is not uniquely determined. So the key point here is that when n plus l minus 2k is greater than n, then the polynomial is uniquely determined, and it cannot be corrupted because because the polynomial is determined across all points. But if it's less than n, then it can be corrupted as a polynomial is not set. We need n points to determine an n minus 1 degree polynomial, so there's still some points left to set if this is not true. So we can say that when n plus l minus 2k is less than n, Eve can corrupt. And when this happens, Eve can't corrupt. Sorry for the bad handwriting. So this happens when L, so solving for L here, L will equal 2k. So n plus L then equals n plus 2k. So Eve has to send at least, Alice has to send at least n plus 2k packets in order for this message to be unique.